Apologies, people. Everything doesn't always run as smoothly as we'd like it to. Right. We have Graham Sessions on board with us, but we will come back to Graham shortly. Very quickly, acknowledgements, notices, and housekeeping. All the POPI Act and all the necessary authority has been obtained to make use of all the materials that is involved here. For any assistance, please contact Eloise. You can phone her on that number or the admin email. She is online with us. Any questions, please raise your hand in the background or ask questions. Eloise is online with us. Please note the session is being recorded, so if you are wanted on police file, please keep your face off our screen. Please keep yourself muted and please keep your cameras off. It assists with the bandwidth. As we're going along, please feel free to interject and ask questions, or otherwise ask questions later on when we come to the question sessions a little bit later. Acknowledgements, please. I would like to just say a special word of thank you to our VCO who've come on board as partners for this online information session. Special thank you to our VCO. It's through their partnering and support that we're able to present these sessions free to everybody. Your support on all aspects of road safety through partnering of these sessions not only appreciated, however, is respected in the efforts to assist in some small way in improving the catastrophic situation on our roads. Our VCO has kindly partners with us for 6 sessions for the remainder of the year, this being the first of the sessions, so there will be 5 others going through the year. Please attend if any of the subject matter is of interest to you. All right, these are bi-monthly sessions. They're presented by us. The South African Institute of Occupational Safety and Health team members, SIOSH, that are attending, you get your CPD points. Graham Session, who most of you would now have seen, is online with us. He is our guest specialist that we will be bouncing some questions off a little bit later. So the intention of the session is a brief hierarchical insight to real-world case studies and the nuances, particularly on the subject matter of forensic scene investigation, software and equipment. Please, we're not going to be going into detail in this. This is just to bring to your attention some of the software, some of the processes, what can be done, some of the equipment. It's a very, very detailed, very diverse subject matter. To allow for a brief discussion, question and answer session a bit later on. So moving then into the specifics. Forensics investigation is not specifically just to our field of crash investigation. It deals with crime, it deals with technical cases that we sometimes deal with, perhaps a crane fallen over, perhaps someone's arm unfortunately chopped off in the workplace, and other issues that we sometimes deal with, for instance, heisters in warehouses that have knocked over some of the structures and caused injuries and death and damage. So it's quite diverse. So scene investigation involves the collecting, preserving, documenting, and analyzing of evidence found at the scene. That is the key issue here. And when we deal with this issue of investigation, software and equipment, that is specifically what we are referring to. The field of forensics that involves the examination and analysis of physical evidence collected from the scene. That is the key factor involved here. All right, so before we must say, before using any software, programs, equipment, a very clear and accurate understanding of the how, why, what to measure, and likewise how, why, and what to photograph must be held, i.e. you need to have at least a very good understanding of scene investigation, in particular the technical specifications. Not going to go into that any further except to say it's all good and well that we have a fancy piece of equipment or some software and you get to the scene and you don't actually know what to record or how to record it. If you do not know factors of millimeters, centimeters, meters, degrees, angles, percentages, how or what, straight line or baseline or triangulation, rise and fall, grade, slopes, coefficient of friction, drag factors, PRT, the difference between a yaw and a scrub mark R, among other factors, you should not yet be making use of such advanced software and tools. As with any profession, you obviously start at the bottom and you learn as you go along. So what we are showing you here is obviously software and tools that you can use and can assist you in your day-to-day operations if you work in any of the field of investigation, of any technical scene, but please, we stress that it is important that you at least have a very good basic understanding before you progress onto advanced software and equipment. We're not saying don't go and use it and don't try it, but we're saying be responsible about it. So for instance, you can see here, this is a lot of manual collection as well as where we are using equipment, which is kind of what we are showing you here and what we are discussing. This type of equipment, be it manual or fancy equipment, like we use the Trimble DA2 and TD600 data collection system, or whether you use a total station, or even if you're using manual, you need to have the basic principles and understanding. So we're going to go into some quick case studies before we get to the discussions with Graham. So in this particular case study 1, we use the Trimble Quick Response DA2 and TD600 and the Trimble Forensics Reveal software. The very basic nuts and bolts of it are, it's a commercial vehicle that left the left side of the road. It returns in loss of control across the road. It veers across the road. Please keep yourself on mute, guys. And it strikes the bank on the other side of the road. Obviously, from an insurance perspective, please put yourselves on mute, please, everybody. There's lots of questions. I'm not going to read through all those questions, but I'm sure, as all of you will know, a lot of you from the insurance industry would want to know, where did the impact occur? Why did they lose control? What was the speed? So going to the scene and using this kind of equipment and software, as we're going to highlight, helps you answer all these questions. So there's a very basic for you. You can see it's a long, straight, typical section of the N2. You can see some of the evidential marks on the road. This is what we want to record and analyze. And you can see there has been some impact with the curb on the left-hand side. So there we are using the actual equipment, the physical equipment, which involves the software on the equipment as well. In particular, this is the Trimble DA2 and TD600 data collector. And in a very simple overview, it comes out as all of these coordinates from the device. And there you can see, using the software, it comes out into a pretty picture, a relatively accurate pretty picture, and we can do various analysis from that. So that's your case study 1. You can see in particular in this case, we wanted to know what was the speed of the vehicle. So because we had recorded everything accurately and we had all that level of detail, we were then able to calculate, as you can see on the bottom there, between 105 and 135 kilometers an hour. So that's an example for you in case study 1. Case study 2, we included this because you don't always need to use fancy equipment. We talk about this Trimble DA2 data collector. We talk about the total stations. We talk about scanners. This is all quite expensive equipment, and we don't always have access to it. However, there is very often opportunity, as we do in probably about 50% of our cases, where we still do old school manual measurements. We may not be able to take the equipment with, or it's just simply quicker to do it. In this case here, we have a motorcycle turning right at an intersection, a Mercedes sedan traveling straight through on the main road. The vehicles collide, serious injuries, and there's a whole lot of questions. So there's a synopsis for you of what we're looking at. Typical intersection, where you can see my mouse. That is the rider. Just past them is the motorcycle, and further up the road is where the vehicle came to rest. In this particular case, you can see this is actual video footage that you're looking at. It's not a photograph. And there you can see we've used the software, and we've been able to rebuild that entire scene accurately to scale. We're able to put in where all the video cameras are. We're able to put in where all the photographs are, where all the motorbike and the rider came to rest, where the vehicle is, etc. And then you are able to make certain analysis from that. In this particular case, it was what we call a line of sight issue. So we were very interested to see what the two vehicles could see of each other. And we're providing you this video clip because this is recreated for us so that the court could see what either rider could, the driver and the rider could see as they were traveling. And so it's an example for you of how the software and equipment can help you.
Hi, good day. We lost sound.
No, you haven't lost sound. I'm just keeping quiet while the video is playing so you can watch the video.
Ah,
Okay, so if you are making use of either manual measurements in this case or fancy equipment on the scene, the software that you can use and get provides you with some very powerful tools that you can do. Case study 3, Lucas is online with us. We'll chat with Lucas about this scene a bit later, but in very brief synopsis, you can see there's a lane of travel, a lane of travel. You can see there's one vehicle and the other vehicle. This is essentially what we call a faked right type crash. In other words, where this vehicle was on the wrong side of the road, now he's coming back and the other vehicle is swerving to avoid. Lucas, we'll chat with later, will tell you that in this particular case, what was crucial here was to actually look at the damages to the vehicle in order to orientate the vehicles relative to one another. This was a great case, and I asked Lucas kindly to include it with us. Thank you, Lucas, because what you will see is Lucas used photogrammetry in this particular case, another piece of software and equipment that can be used, and Lucas will chat with us just now about this. Basically, he took a vehicle, as we see in this diagram here. He's photographed all the way around it with a particular software and photographs, and he was able to rebuild these vehicles to scale in 3D. And as you can see there, he has it. He's put them back together, and so you can determine quite accurately, probably with a couple of millimeters or centimeters, how the vehicles have struck each other, the angle that they've struck each other, and that's very, very important in a case. So thank you to Lucas for that. We're starting to see more and more of this use of 3D scanning, 3D clouds, and photogrammetry. Some of you would have seen this before. So huge case. This was Fields Hill, the truck that came down Fields Hill and wiped out 14 vehicles and killed 23 people. So this is how we started off on the scene. In this particular case, we were using a total station. So that entire scene is fired with a total station. It basically gives you a whole lot of points. It allows us to build that scene very accurately from that, including all the evidence. It allows us then to go into the next diagramming and show where everything was. It allows us to calculate all the distances, all the movements, etc. So it's just a great example for you of just how detailed you can get if you are using all of this equipment. Case study 5. Sensitive issue. This is using drones. We use a drone. We are qualified drone pilots within the company, and if and where we can, and I say that with a pronounced if, where and when we can, we do a scene with a drone, and we can pull those images in to the various software, and it does generally save us a lot of time, and it is far more accurate where we can, and use those. So I note with particular emphasis here, please people, using a drone in South Africa, you have to be licensed. You may not fly a drone over the roads, etc. We're not going to go into that subject matter here. We're just showing you that it is an option. You can use drones. You need to have a license. You need to use it within particular parameters. But there, for an example, is an example of a drone photograph. You can bring that into the software and you can measure all of these marks very accurately in great detail. It is a really nice piece of bolt-on equipment and software if you do have access to it. I've put this in particular because we see a lot of this, the use of Google Earth. Google Earth is in itself a software platform. There tends to be a lot of use of this in a lot of forensics investigation cases. It's fine. You can use it. However, it is a very good tool. Google Earth can only be used for general indications, such as directions, general layout, road markings, etc. Google Earth cannot be used for actual measurements. When I say actual measurements, I mean accurate measurements. If you are trying to determine which vehicle impacted on which side of the road and you are down to a couple of millimeters or centimeters, you cannot use Google Earth for that, contrary to what anyone will tell you currently. Manual equipment measurements in the field is required. So whether you're going to the scene and manually measuring or using any of this nice equipment that you see, the total stations or the quick response tools, you need to do that. There's various research papers that you can refer to that will show you the error. Nonetheless, Google Earth is a great software to be able to use to show the general layout of the road, the positions, the directions. It does have street view. Please keep in mind, Google Earth are historical images. Some people still seem to think that Google Earth is a live camera floating in the sky. It is not. They are images that are pre-recorded and therefore are dated. All right, so nearly done. In overview, forensic scene investigation software and equipment. In terms of other software and equipment that can be used, we're not going to get into this because this falls into the realm of advanced investigation and analysis. But with most of the software like the Trimble Forensics Reveal, Faro, PC Crash, many of the forensics investigation software programs, there are calculative programs within that that allow you to do various analysis calculations, etc. Great to have, but also very, very dangerous if not used properly. So please just be aware of that. In terms of other on-scene investigation software, you can use a VC DAC, what we call a DAC. That's for measuring skid resistance. However, old school equipment, what we call old school equipment, manual drag sleds measuring the resistance on the road, or a set of steps if someone's slipped and fell, is still acceptable. And you'll see I've written there obsolete. No, it's not obsolete. We've all moved on to modern software and technology, but you can still use these. They are still acceptable. And remember, they are the basis on which all modern technology was derived. Here we see top left corner for you what we call a link stick. Before we had drones and Google Earth, we would put a camera up on a link stick. Graham, interestingly, you assisted us with some triggers for that, if you remember. Bottom left, you will see there is a beautiful X9 Trimble 3D scanning device. The one we currently use, which is the GNSS-based DA2 data collector and TD600, DA2 and TD600 data collector, and one of our old school Nikon total stations, which we used. The beauty of these two new devices, the one that I'm circling, they are single users. Any single person can take it, go to any scene or forensic scene and can go and record all the data by yourself. You don't need a second user, except for someone to watch your back because we live in South Africa. Other equipment, there's lots of other equipment you can use. This is particularly for commercial vehicles. Gradient gauge you generally would not use anymore if you're using any of the modern technology, because it will automatically pick up for you grades, slopes, horizontal alignments, etc. But as we've said, none of the old school equipment is obsolete. You can still use it. Top right-hand corner is a light meter. You would often still use a light meter if you have a nighttime scene. Moving on in finality, if you're really, really up to scratch, some of the very latest equipment is Scene Pro in the UK. Very, very expensive equipment because of the exchange rate. But we use the DL1 data collector for some of our testing. You can also use VBox, and there's also lots of other equipment that you can use if you're doing after crash evaluation and scene investigation. So to sum up, there is lots and lots of software programs, hardware that's available. In particular, we use the Trimble Forensics Reveal software, which is supplied by Optron in South Africa. But there are many others, and we're highlighting those to you so you can do your own investigation to all of these. Analyzer Pro, PC Crash, CrashLab, Virtual Crash, Map 360, Smart Draw, Easy Street Draw, Accident Sketch, CSI Mapping, Analysis Alice Dana, Carlson, Photo Modeler, Photoscan Agisoft, Faro, PedBark, Pix4D. There's lots and lots and lots of them. In particular, the two that you saw, or the one in particular that you see that we use, the Trimble DA2 and TD600. If any of you do scenes, you would be very interested in seriously considering that option. Right, that's enough talking from my side. Graham, we're going to bring you in here, and Lucas as well. Let's just have a little bit of an open floor chat between of us. So first of all, Graham, just from your side, I have your resume or CV. Graham has basically been in the, if you want to put it that way, investigation field from the perspective of the equipment. Graham, as you were saying earlier on, from around about the 1970s. So I think you have, give or take, 30 or 40 years experience of looking at us growing to use total stations, scanners, and all this. Just some comment from your side?
Yes, absolutely, Craig. Thanks very much. I hope everyone can hear me. Okay, does it seem to be okay? You just give me a thumbs up. Good. Yeah, I mean, I go back right from the days of the optomechanical theodolites, in actual fact, where everything was manual. And then, of course, the introduction in the 80s of, first of all, EDMs, which came in, and then somewhere around about the middle of the 80s we started seeing the first introduction of total stations, which revolutionized the surveying side of things, because then you could start using data capturing devices to do point cloud or point measurements, essentially, not point clouding or anything of that nature. Yeah, and it's been tremendous to be in this particular era. In actual fact, I've seen from the mechanical side right the way through to the scanners, to introduction of first kind of 3D measurement processes, and it's been an exciting time. And from my perspective, obviously, I concentrated on the software side, writing applications when total stations came into being, specifically for land surveying, but then adapted that land surveying software to accommodate accident investigation and crime scene investigation. And that came about in 1994, round about there, when there was a mass exodus of expertise in the South African police force specifically. So the local criminal records centre requested that I produce an application. In those days, obviously, I'm sorry, just stop me if I'm talking too much. In those days, obviously, there wasn't specific accident investigation CAD programs. So in most cases, some people used CADI, which was one that the local criminal records centre used, and then there was AutoCAD, and then there was early stages of TurboCAD, but none of them specifically geared for the accident investigation field, with facilities to include objects, etc., pre-drawn objects I'm talking about, and having statistics on motor vehicle center of gravity, etc. So it has been, and then of course one sees the introduction later on of the photogrammetry, which was also a very, very specific field for people in the mapping environment. So the specific product that I represent, in actual fact, a Canadian product called PhotoModeler, they were the first company in actual fact to use commercial cameras to do the photogrammetry tasks. Prior to that, it was a very much a domain of photogrammetrists, etc., to produce mapping. So they also saw the advent of introduction of the uses of commercial cameras and the use thereof in the field of accident investigation. And then, of course, photogrammetry is now tying in with the laser scanners, because there are certain strong points for laser scanners and there's certain strong points for photogrammetry. And each of those particular instruments or those particular tools don't cover the entire spectrum of measurement. And one is good for one type of application, the other is good for another application. So now there's the marrying of the two technologies, and obviously, if one can afford it, you really are a for away when it comes to being able to do it. And then obviously the export thereof of the results into a analyzing program, CAD program alternatively. So
let's break that down a little bit, Graham, for them. So to synopsis that in a very simple layman's term, essentially what the crime scene investigation and crash scene investigation has done is we've made use of, to put it that way, most of the development that's come from the civil engineering side, and we've just adapted that across because essentially we're measuring objects the same as they do for a civil engineer.
yeah, absolutely. That is absolutely correct, Craig. You know, in the early days of mapping accident scenes, I think those that have come from a police background would have known the trilateration, the tape measure, putting out a baseline on the side and mapping it. And once those expertise for drawing those plans, those accident scenes and crime scenes, happened in the 90s, the early 90s, then we had to look at alternative solutions, simple solutions, which resulted in me writing an application called SAPServe, and that was that I took out all the technical terms that are used by land surveyors and made it a simple application for a non-technical, non-land surveyor, non-engineering surveyor person to use, but still get accurate results.
So let's take that in context. So essentially, let's jump forward now. We've now moved to the point now where we are using this equipment, whether it's a total station, a 3D laser scanner, whether it's photogrammetry. But let's contextualize that. Anybody that's using this equipment still has to have the necessary training and the basics understanding, which is kind of what we were showing in the lead up to our discussion with you. So that leads to my question too, the need for grassroots understanding of the basic principles and theories, the correct operation of the hardware. So just some comments from your side of anyone that's thinking of now moving into using this kind of software and hardware that's come across. They must have that basic understanding and training.
Oh, absolutely. You're absolutely right there. One can't just throw a piece of equipment at them and say, get on with it. They've got to understand, to a certain extent, even with photogrammetry and also with laser scanning, one has to understand simple things like where's the most optimal place to set your equipment up to start recording the scene, and ensuring that when you do that, that you know that if you were to move that piece of equipment to another position so that you can actual fact adequately cover other areas, that you know how to do that functionality. So it's not just a case of, well, here it is, throw it in, you know, and move to another spot and start measuring, and then you'll find that the two sections are just not connected with each other, etc. And so there is training involved with the theodolites, there's training involved with the scanners, there's training involved with photogrammetry, there's training involved with any of these particular methodologies, even when it comes down to like using surveillance cameras, for argument's sake. So that is important, and it is necessary to teach and hand that over to when you hand over the equipment to the suppliers. Okay, I'm not endorsing any specific supplier, but they do have the technical employees that work for them that could teach them at any rate.
So anybody that's looking at buying, let's say, for instance, the Trimble DA2 and TD600, they're going to get a cost, and they buy this equipment, and they would then obviously need to do the basic training. So that's great. Graham, just moving on then, so on that aspect, there's a wide range of hardware and software. Again, we're trying not to endorse any particular equipment. Obviously, I love the equipment that I use, but there's many makes and models, like a car. I mean, some would argue that BMW is the best, or Audi is the best, or Volvo is the best. So some comments on that. Lots of different products available. Any pros and cons to them?
Absolutely. I don't think there's a bad instrument these days that you can say, okay, that's a terrible piece of equipment. I think there's definitely the older traditional suppliers that come through from Switzerland, like Leica and so on. But and obviously Trimble is a good supplier. There's Topcon, which is a Japanese company. There's quite a few Chinese machines that are available on the market. But once again, I think in this country, one has to actually look at the supplier. Is the supplier going to be around next year? Is the supplier a reliable supplier, etc.? And I think that's it. And then obviously the best equipment is what you can afford. I think that's it. I mean, you're going to make the best solution as a user with the equipment that you can afford. So I think when it comes down to GPS, I heard rumors the other day that there's now about 15 suppliers of different makes of GPS equipment, which is all very accurate nowadays, because you can get your measurements corrected by going, through the Department of Land Affairs, who have set beacons around the country to correct your signal. So once again, it boils down to what you can afford, and I think the supplier in this country is important.
Well, that's good comment.
Photogrammetry software, there's obviously 2 or 3 solid suppliers in this country with solid products. Some of the photogrammetry products concentrate purely on the mapping aspects. They're not very versatile. They're very good at what they do, and then there are other photogrammetry products which are more widespread and versatile, which is obviously one has to actually take into consideration, and price is a consideration there as well.
So yeah, I'm always, Graham,
boils down to price.
Yeah, I'm always trying to break this down, for some of the attendees, because not everybody is absolutely technical, and not everybody has always had the opportunity to use this equipment. So, to synopsis what you've just said, lots of different software, lots of different hardware, literally the physical devices we use, lots of them cost a lot of money because they come from America, Europe, so there's always the exchange rate, and the big issue being that a lot of them are capable. And if someone is going to consider buying those, it's not necessarily so much about what they can and can't do. Usually it's a cost issue and it's a backup issue in terms of learning to use the equipment, and if there's a problem, long term, having someone to support them. So yeah, good points.
The other thing, just a quick one, is also the accuracy of the instrumentation you can buy. You can get, for instance, theodolites, you can get 1 second theodolites, or sub 1 second in terms of accuracy, angular accuracy I'm talking about, and total station distance accuracy, etc. So it's important to actually look at that. But then you can maybe use a slightly less accurate instrument if you are working closer to the subject. It's the closer you are to the object that you're measuring means that you could possibly downgrade your level of angular accuracy and so on. So if you're working over great distances, then you want to go for the highest accuracy. If you're working at shorter distances, which in the most case you are doing in accident and crime scene investigation, you can use a less accurate theodolite, which will be a less expensive.
So again, breaking that down, Graham, for those in attendance, in general, the equipment and the software we use comes from, so to say, in the broader scheme of things, the civil engineering, who are always pushing the tolerance down to literally the millimeter and sub-millimeter. For us, generally in a crime scene, unless we're measuring the diameter of a blood spatter mark, if we're getting down to, a couple of millimeters accuracy, which almost all of this equipment is capable of now, it's generally not a problem.
Yeah, it's not a problem. The closer you are to the object, in actual fact.
Yeah, well, that leads us to question 4, which says, key benefits, detailed accuracy, and perhaps some negatives, perhaps not always quickest, and using the software. So, just Graham, maybe some comments from you on that side. I think to myself straight away, and I know this because we've had quite a bit of this equipment. A lot of it is very expensive, so that's a negative. And realistically, often for people, there's a steep learning curve, and adaptation both to the hardware and the software. But also a negative is sometimes some of these things are not quicker on the scene. They can take some time, whereas I could quickly take 3 or 4 manual measurements and be done and flee the scene quickly. But definitely the positive of this equipment is, the fact that once you use it and record everything, it's done. It's absolutely accurate. Just some comments from your side on the pros and cons.
Well, the pros and cons of having, okay, maybe I'll address this in a different way. Okay, if we take laser scanning as an example, for measuring up a crime scene or measuring up an accident scene, there is a time component built there. Obviously, there's been studies on when they have a freeway accident, how long it takes to clear the accident if you're recording it. So if you were going now with your scanner to just go and scan the scene, the time constraint to actually capture the data is longer than if you were to, for instance, put up a drone and do a video of the whole scene from a vertical perspective to map that particular environment. So the scanner is a great thing if you are at an accident scene where the vehicles are still in situ and so on, because you can get a very accurate result. You can come back and you can put that into your CAD application. By next morning you could have a result. But from the perspective of clearing the accident scene, photogrammetry is much better in that respect, is that you can arrive there with your camera. You can do it terrestrially, in other words, walk around the environment and snap the pictures with your camera and then come back. But it takes longer when you are back in the office to process that information from a photogrammetric perspective. Theodolites would take even longer than the scanner. The second issue is where photogrammetry is more, maybe I'm just using this, is that photogrammetry can be done on a moving platform, where scanning you can't do scanning on a moving platform. So you can't put your scanner up onto a helicopter and then just say, right, or your drone, and go and map it. Obviously nowadays there are drones with mapping scanners, but they are even more expensive. They're called LiDAR, and they are even more expensive than the scanners that are terrestrially or put on a tripod and so on. So yeah, I think capturing information at the scene, you have to assess it. You have to decide which is going to be the quickest and which is going to be the most accurate. If you arrive after the accident has happened, then obviously you have a little bit more flexibility in terms of there's no time constraint or anything of that nature. But yeah, much more.
I think the difficulty then is, I think what you're saying then, Graham, is that technically we need to find a couple of million and have a scanner and a drone and have all of them available.
Well, from the drone side these days, of course, they are incorporating scanners into drones now. So those are
I think the thing is here is that, look, I think the vast majority of people that are attending here are people that would deal with the scenes after the fact, much after, days after.
In which case, any technology would be perfect to work.
Yeah. There are some that are on here, Lapis and Gary Ireland and a couple of the guys from the SAP that are online here. I mean, obviously, if they were to look at equipment for themselves, then they would, keenly be looking at something that they could use on an active scene, so to say, as quick as possible. So I suppose it's just a case of weighing up whatever software and technology is available and best for your fit. Graham, fair comment?
Yes, I think so. I think as I've always said to any of my clients over the years, the best equipment is what you can afford, and you will create solutions. It's not easy for someone to just go out and fork out R1 million, to get themselves equipped with the latest and the greatest, because you still got to learn that technology and so on.
Yeah, for sure.
I think what is affordable, what is reasonable, and if it's going to give you the kind of results that you're looking for, then go for it. I mean, there's still the manual method of measurement and so on, which is still very valid, absolutely.
Just on that point, that will never go away, and everybody in attendance here, as we have pointed out, it's a nice to have. It's not a have to have all this equipment and software. You must always remember you can go back to the basis. Graham, just touching on that issue then. So one of the things that everybody needs to keep in mind is, and this is something that is often forgotten, going with any of this new equipment, both the physical equipment as well as the software, besides the exchange rate, the ongoing costs of these things in terms of licensings and updates very often sees further costs involved. And I think that's something we need to highlight and that any potential customers need to be acutely aware of.
Absolutely. You know, if I look at photogrammetry software, which because I haven't a clue how much total stations are costing these days, or theodolites, but I mean we're looking at sort of starting price around about 60,000 Rand for the photogrammetry software, which will do everything. Obviously, you can go for a slightly less package, and then the yearly subscriptions work out. What are we looking at? Around about 2,000 or 3,000 Rand or so. You know, maintenance to keep the software current. That's if you can still use the software, and I'm referring to the software I supply, as you are fully covered for the first year, and then thereafter, if you choose to upgrade or not upgrade but keep current, that's fine. You know, you can pay the maintenance cost, which is about 3,000, and if not, then you stuck with that version. That's it, and that version is a permanent license. So yes.
Well, just on that issue, then, just, you know, for everybody that is in attendance, if you want to give myself or Optron a shout, I can tell you now that we've extensively looked at all of the stuff, and currently the DA2 and TD600 data collector that we use is one of the most cost effective on the market, and it still costs a lot of money, but it is most cost effective. Lucas, I'm going to bring you in here if you want to just come back online with us, you know, on this issue, touching, Lucas, on your case. What's your comments on using photogrammetry, 3D scanning? It's something that you've become quite proficient at and have used in quite a few of your cases that we've chatted about. And Lucas is a fellow colleague and expert as well, one of the top guys in South Africa. So lovely to have you on board. First of all, Lucas, just some commentary on your input on what we've been talking about.
The learning curve is huge. Yeah, I've been working with Graham since we first started off with the dollar stations, but as involved, it took a long time, Craig, to develop. You know, it's not the thing that's happening overnight. A lot of reading, a lot of research. It took a lot of research and a lot of reading to get to a point where you can 3D model these vehicles, or 3D model scene. And although the technology is out there, but the learning curve on it sometimes is a bit longer than what you expected. Now it looks much easy because you look at it and it's so easy to do. But you know, initially when we started off with that, we were virtually the only the first persons that was doing it in the country.
So just as a matter of interest, Lucas, just walk us through this particular one that you did. I mean, you know, you and I have chatted briefly about this, and
yes.
And it's my indication from you is that you used your iPhone and your LiDAR system on this, and this is what you created. Give us a bit of a heads up on this particular case.
There's two separate cases on this one. The one is a Mercedes-Benz and a Opel Variano. That's it. The two that you can see in the top left one is a Renault and a Hyundai that was involved. That was the example that you showed right in the beginning. And the issue was on which lane did they action? Well, most of these cases evolve around, you know, where was the point of accident, the area of accident on the road from the marks, because most of the time when we arrive on a scene, some of those marks are already faded. Some of the more prominent marks that you will find is gouge marks, but tire marks, they start to fade very quickly. So by placing these vehicles together in the accident reconstruction field, you get a much better understanding of the dynamics and the behavior of the vehicles before, during, and after the crash. So virtually what I've done here is we just walk around the vehicle. We overlap, and most photogrammetry software has this availability for them. We have to have a good overlap of the photos. We walk around a photo like you showed there on a slide, and we take lots of photos, but not just on one level, but on about 3 or 4 levels. And then you use your photogrammetry software to build a 3D model. And from there on, what I did is I use a software Cloud Compare, where I physically then start to move the vehicles to match the impact areas to each vehicle. So you can see exactly how they came together on an impact. And then from there, you will place it back on the scene. You're gone, Craig. Cannot hear you.
Sorry, apologies. So just to bring that back to layman's terms, so you literally used your iPhone, which anybody could have. You've used a software program called 3D Zephyr. You've processed all your photographs. I'm really simplifying it now. As you said, it's a steep learning curve. And then you've used Cloud Compare, and you've brought the two vehicles together. So it is something. It is an alternative option to perhaps our DA2 TD600 to a total station, that somebody could use this kind of software and literally use their phone, or as Graham has said, photogrammetry, which is a similar kind of software using photographs.
Yes, we've been also successful in the past where we used some police photos where a police officer walked on the scene, and just by the way he walked on the scene, you were able to get a fairly good idea of where the tire marks were at the time of his inspection of the scene. But in terms of vehicle, like you did here, you're sitting with lots of problems, and Graham can elaborate here as well. A vehicle is very shiny, and scanning software, like we did here, is very difficult on shining material. It doesn't like shiny materials. You have a lot of struggle. So in most of these cases, vehicles were already covered with some sort of dust, which aided in the processing for us. But it is possible, yes.
But again, so these are these learning curve things that once you go across to some sort of new equipment on the scene, whatever that may be, as we said, the whole list, or software, there's an inherent learning curve. And I think the point being is we're just trying to highlight that there are these options out there to the investigators on whatever scene, and it can be used. Just coming back, Lucas, moving on to the next question at 7, and Graham, also commentary from your side. We ourselves use a drone, and we use it fairly regularly. Lucas, I know you do as well. Just some comments from your side, Lucas, on the drone. Convenient thing to use, good thing to use, effective, something somebody should look at?
It is, Craig. However, like you mentioned, a droning licenses is one. You cannot fly anywhere, and then there's restrictions. Some of the drones will not fly in the restricted areas. The other problem is that we picked up, and most people tend to forget about it, and then Graham can elaborate more on it. The drone image is a top-down photo. The ones that we are using is ortho photo, is the perspective and distortion, lens distortion has been removed by your photogrammetry software. And that is important. It's not just a photo and you can work with it. That image that you get from a drone needs to be processed to an ortho perspective image, so that your lens distortion and your perspective correction can be done before you can just take measurements, all of that on a photo.
Graham, bringing you in here, just some comment from your side and relating that to the issue of...
Right. Yeah, there's a couple of advantages. Obviously, the other one, which is from a photogrammetric perspective, is the fact that you can also get a contour layout of the terrain. In actual fact, the side of the road. In some cases, you can even see rutting in the actual tar. which may have caused a truck to veer off to the left or veer off to the right. So it is a useful tool from that perspective, that it is able to give you a top down, but it will also give you a perspective of the actual gradient of the road surface, etc. And obviously the cross sections. You could do cross sections across a road surface, which you can then see the actual rutting if it has been caused on the road. So it has its advantages, definitely, from that perspective. Having said that, you can also get by, obviously, and do similar things with a link stick and a camera, and get the same kind of result. Just it takes longer.
So putting that back to layman's terms, what both of you have said, and thank you for your input there. So just for everyone attending, back to break that down, we have these lovely things like photogrammetry, all the software, drones, etc. But it's not always as straightforward as just putting the drone up and taking a photograph. It's got to be processed. It's got to be manipulated. And Lucas, that comes back to what you're saying. There's a fairly steep learning curve to these things. So they're great to have, but everybody needs to understand that it's not just click, take a photograph, and there it is. Fair comment?
Absolutely, Craig. If I think back on a time that I phoned Graham and we had long discussions and trying to work things out, and it's not just overnight. You know, you need to get along somebody that's already doing it that can help you along with it. And what Graham was saying, you know, you always thinking about, so drone is the new toy in the field, which is not always the case. And you mentioned it earlier on. If you don't know how to do the basics, buying these new toys or technology or equipment can assist a lot. But you know, and what Graham alluding to, you know, as an example, just using a drone as an example, the same results can be accomplished with a link stick. And there's a lot of cases that I've make use of a link stick to build an auto-corrected image without a drone.
Okay, moving on a bit there then, Lucas, maybe just keeping you in on this one, and it's something I just wanted to reiterate, although we did mention it earlier on. You know, a lot of these software that we use in the forensics field in terms of crash or technical on-scene investigation, they have a lot of these calculative programs, which I use, you use, and some of our other colleagues use. They're dangerous, and we just wanted to reiterate that they are dangerous things. Please, people, don't think that you can just suddenly buy the software and all of a sudden just it's going to predict for you what happens. You know, you need to know the weight, you need to know the angles, you need to know the loads, you need to know what a coefficient of friction is, all these things before you can actually use that software. So just reiterating that and saying, guys, please be careful with that. Lucas, a comment to that effect on your side?
Absolutely, Craig. You know, we've seen it so over the years, and we've been involved in this field for a long time now. We've seen people, a new software will come out which can do calculations for you, as an example, and they will use the software and think all of a sudden they can do reconstructions. The software, the technology that's available is there to assist and aid, and it doesn't make you a reconstructionist for that matter. And we've seen it a lot, especially now with the CDR or event data recorders that's on there, and the same with drawing or CAD packages that there's a capability of doing calculations for you. If you don't understand the fundamental basics behind the reconstruction or camera work or measuring, it's very dangerous, and I will caution against it.
Thank you for that. I'm just answering quickly. We're going to move on to one or two more questions and then we're pretty much done. But guys, if there's any questions from you, please just feel free to interject, put your mic on and ask questions. Just touching quickly on this question from Yudesh, ready Yudesh, apologies for that. Yeah, and to the question of can these investigations be done simultaneous to the police? I'm not quite sure if I'm understanding this correctly, but I'll give you an example. I live in the KZN region, and because I'm an avid cyclist, I very often get called when there is a bad crash where someone has been killed or injured, and very often I will go out to the scene, and very often on a live scene. We've just had a case where literally 2 days ago, the driver was found guilty and got 6 years charged. And we did the full reconstruction on that entire case based on the photographs that we took on the scene and the measurements that we took, because the police did not know how to do that and hadn't done that. So yes, the private sector can work with the police. Yes, a private forensics analysis can be done by the scene, but there has to be a cohesion and an acceptance and a mutual working partnership. It's not something that we would just go do and take over as a function. So I hope that answers your question. Most of the time, Lucas and I would be involved, and most of the people in this forum would be involved after the fact. Just moving on to some of the other software then. I mean, I know we've been dealing quite heavily with things like, total stations, theodolites, scanning, that kind of stuff, but other software that would assist as well. So for instance, we have the Bosch CDR data collector. There's equipment like Burler that can look at what telephone calls were made and can look at, your onboard tracking systems, workshop fault tools. In other words, if your vehicle goes into the workshop and it checks on things when a fault code popped up. There's lots of other software and equipment that's available that can be quite useful in the field. So keeping all of those in mind as well. Although our primary look at in this session is, generally recording of evidence from a crash site or a technical site, but there are lots of other software things as well. Again, the last point, old school equipment, drag sleds, gradient gauge, link sticks, all those kinds of things, they are not obsolete. Very often you will find they're the quicker, easier thing to use on a simple scene. And they are certainly not obsolete. And these are the things of which the basis of the modern equipment came about. So please don't be shy, guys. Graham, Lucas, any closing comments from your side, guys, and any other contributory questions or anything from anyone else?
No, great. I'm good.
Thank you, Graham. Thanks for being on board. Lucas, from your side, any closing comments?
Thanks. No, Craig, I think you've covered most of the fields. Just as a final comment, maybe get to know the software what you like to use or plan to use. Know the capabilities of the software, and then get to know people in the field that's working with it.
Yeah, great. So guys, in closing off then, I'm going to be online, and I'm sure Lucas and Graham will stay online. Please feel free to chat with us openly. But in closing, as always, if you work in this field, in any field of crash investigation, forensics investigation, there's some really, really interesting research and reading. We make a point of reading literally every second or third day, latest judgments, latest research, and in particular relating to what we're talking about in terms of the equipment available, in terms of processes, procedures, software. We have, as always, given you in your reading research reference in the presentation. It is there. I would strongly recommend that you go and read, if not all of these, at least the first 4 or 5 or 6 of these. They're very, very relevant. Thank you, everybody. The next session we're going to be doing, we will send out the dates to everybody, is commercial vehicle loads. We will look at loading, how to load, legalities, distribution, strapping, and we will have an expert on board for that. Thank you, everybody. Be safe. We are online for a while. Please bear in mind, we cannot touch on everything here. This is a hierarchical overview and just some general commentary on what's available in terms of the software and equipment. So we hope that's given you some insight. Please feel free to contact us if you need any help. Thank you, everybody.